Hello everyone and welcome back to another one of my videos. This time I'm going to be teaching you how a very useful and potentially dangerous component called a capacitor works. Capacitors are everywhere. They are in power supplies, cameras and even audio equipment. The most famous inventor of the capacitor is Peter van Musselbroek, who came up with a contraption called a Leyden jar that had plates of metal and a rod that could store and discharge amounts of power. The concept of the Leyden jar is still used today, but with some modifications. Inside a modern electrolytic capacitor, yes, there is more than one type, there are two layers. One of those layers is a paper or tissue substance soaked in a special fluid called the electrolyte, which insulates the two plates that connect to the positive and negative terminals of the capacitor. Those two plates are most commonly made of a thin metal film that are wrapped in a spiral with the insulating material. The size, thickness and shape of the plates can be changed to increase the capacitance of the capacitor, as well as the voltage tolerance. Electrolytic capacitors are also one of the most dangerous capacitors if used incorrectly. If they are connected backwards or overloaded with voltage, then it's not going to end well. Another type of capacitor is a ceramic capacitor. These are much smaller than electrolytic capacitors and hold much less charge. It has a similar structure to an electrolytic capacitor, but instead of fabric as the insulator, they use ceramic, hence the name a ceramic capacitor. It still has a thin metal film for the plates and has thicker connectors at the end which connect to the board. One of the properties of a capacitor is that it can block DC voltage from passing through and the electricity will be stored between the plates of the capacitor instead. Capacitors used in audio amplifiers take this feature to their advantage, as the capacitors stop any unwanted DC voltage passing through into the speakers and causing the coils to overheat due to the constant voltage, as DC has a fixed amplitude and does not oscillate unlike AC. In power supplies, large capacitors, generally bigger than 1000 microfarads, are used to smooth out the voltage, especially in a full bridge rectifier. Learn more about them here. The capacitor is placed in parallel with the DC output and stores part of the bumpy voltage, as the DC voltage cannot flow through it. In simple terms, as the voltage drops, the capacitor releases some of its energy to keep its input and output voltages balanced. Finally, camera flash systems simply consist of a large capacitor that is charged with very high voltage, about 200 to 300 volts DC, that is then released all at once into the flash tube to produce the bright light. That's going to be it for this video. I hope you learned something, and don't forget to like, share and subscribe. Comment down below if you have any future project suggestions, and I'll see you in my next video.